Thank you. Yeah, so I'm actually thrilled that so many people showed up. This is really cool, you guys, and I'm really happy to use this space. We've been here since like August, our company in this building at least. So I'm, really thrilled, happy to see all you guys. And I hope to speak with more of you after this. A couple notes before we begin. We are recording this, just so you guys all know. We thought we were going to stream it, but we're not doing that. Probably doesn't matter to a lot of people at the moment. So a quick show of hands, how many of you guys have used Rust before? Yeah, that helps. How many people have just checked out Rust and not used it or anything? Okay, how many people who have never heard of Rust? Yeah, a couple people?
Jake, the toilets, you should also mention that.
Yeah, the toilets have heard of Rust. They're right outside here, so if you need to go, And there's one here, so that's taken up, go all the way down and to the left around the corner, so just, you can't miss it. Or well, just keep going. So did anyone check out, actually how many of you guys are using Rust professionally?
Oh.
Okay, interesting. That's more than I thought.
0 was already
1. Okay, did any of you guys check out my GitHub before this talk? I didn't ask anyone to, I just know it was posted. Yeah? The reason I bring that up is because one of the things I want to mention is that I'm someone who used Rust a lot, but one of the things I definitely tend not to do is web. It's not that I have some aversion to it, you won't be hearing a lot of that today, so I just wanted to say that up front. Also, another thing is, if you guys could please hold questions and stuff until the end. I'm going to talk for a bit, and then I really want questions after that, because I would love to just hang out and talk about stuff after the initial presentation. So who am I? A little bit about me. This one took me a while to figure out. Anyway, I'm mostly a graphics and systems programmer by trade and hobby as well. I work professionally here at Fuse with dev tools and compilers. I have no relation, so my alias in a lot of the net stuff is Ferris. That has no relation to the Rust mascot, who is also called Ferris. That is totally coincidental, but kind of fun. I do a lot of hobby projects, mostly focused on Demoscene, emulation, audio production, that kind of stuff. I do a lot of streams. I'll have some links about that if you guys are curious to hearing more about a lot of these projects. I do a lot of live coding in particular. I do a stream every Thursday and every Sunday. So if you guys are interested in just seeing more Rust, then that's a place to do it. I like really low-level things, and I like higher-level abstractions. I'm really into FP. I'm also really into assembler, and Rust is kind of a place where they meet. At least I feel that way. And I really like talking about stuff, so that's why I'm up here. Hopefully not making an ass out of myself. So what is this talk actually about? The title I posted was a little bit vague and confusing, kind of on purpose. So when I talk about Rust, which I do a lot, I often get this question, what is Rust actually good for? Where would I actually use Rust? And that's kind of a good question. Basically, I don't really have a lot of answers, but I get a lot of these other variants of this as well, like why don't you use a real language or bad? It's kind of an interesting question, but my honest answer is I have no idea. I don't know what Rust is generally good for, to be honest. I just know that I use it quite a lot, and I've used it since about early 2015. So I've been around since Pre-1.0. And so I thought what I could share is at least some experience, some of my experience in a lot of the projects that I've done, some of which have quite grown a lot in scale. So at least I should be able to show some of that kind of stuff. So this talk is really about just kind of one guy's experience. It's very subjective. I don't want to talk about necessarily, I do have some opinions about Rust as a whole and my experience, but of course take it with a grain of salt. I'm one guy, and that should be important. And I don't want you to think Rust is really great for only one type of project. This is the type of project I can talk about. I'm also not trying to sort of sell you guys on Rust. I mean, I think it's awesome, and there's reasons I really like to use it. I mean, I guess if you're here, I don't really need to either way, but yeah, I mean, I don't really care if people don't use Rust. I think it's cool if they do, and they're probably better off if they do. Anyway, so I also don't consider myself a Rust expert. Like I said, I use Rust a lot, but I'm regularly a bit behind with latest features and crates and stuff. I try to read the Rust Weekly, or This Week in Rust thing, which, by the way, is awesome. But sometimes I fall behind. Doesn't really matter. And I haven't done any web with this stuff. But I use Rust all the time, do a lot of personal projects, and if nothing else, I hope sharing this experience is interesting or insightful in some way. And if you guys don't think so, well, enjoy the pizza and beer, and good to see you. So how did I get into Rust? I just want to talk a little bit about this. I wanted to make emulators, and I've always been interested in compilers and hardware and that kind of stuff. And I started thinking around a time that I was really getting into FP about what would a functional language without garbage collection look like, and how could I make emulators in that. And I just had those ideas floating in my head for a couple months, not really acting on them, just kind of thinking about it. And I started thinking about ownership of things and like, yeah, tracking ownership of objects and what that would look like. And I just started brain dumping on this guy, Chris here, who's one of my colleagues at Fuse. And he was like, you know, that sounds like Rust. And so I grabbed the ebook and I left on a plane the next day and I read the whole thing. And I thought it was awesome. I was really excited. So that's what that was. Like I said, a lot of the ideas are similar to kind of what I already was thinking about, but they actually existed and they were real, which meant they were better than my ideas. This was pre-1.0, very pre-1.0, like a couple months before 1.0. I think May 2015 was 1.0 in Rust. It was an interesting time because it was like all the ideas that are in there now were there already, except a couple details. But so like the green threads were gone. A lot of the syntax was weirder. Syntax was gone. But it was still kind of unstable. Like a lot of things were changing. And particularly, I remember one of the things that was kind of interesting is they were taking a ton of stuff out of the standard library and out of the language. And this was an attempt to stabilize things before 1.0, because one of the goals of Rust has always been to be stable as they release new versions, which I think is fine. But it made it kind of hard to use a lot at the time. It was breaking a lot, but after 1.0, it's been awesome. They've been really good at keeping things working and introducing things that people actually want. And I think this year, in particular, is going to be a really exciting year for actually using Rust effectively in terms of features like non-lexical lifetimes, incremental compilation, those kind of things. So excited for that. I won't be talking too much about that today, but I'm excited about it. Yeah, I think I still tried to use Rust a lot around 2015 throughout the year, and by 2016 I was basically using this for almost all my personal projects because it just keeps working. So again, I just wanted to share a lot of the experience that I've had in some of these projects and talk about them. I want to take a somewhat high-level look and also want to look at some code just to share some stuff and reflect on some positive and negative points about using Rust just on some projects. So yeah. So I went through all my GitHub repos from 2015 to now, and I have 52 repos, which it's just a number. It doesn't really, not that important. So I wanted to figure out which one of these do I talk about and that kind of stuff. A lot of these are open source, some of them are closed, a lot of them are pure Rust, some of them also aren't. A lot of the projects I'll talk about today are Rust within the context of something else. Don't worry too much about a lot of the names of these, a lot of these are crap. So there's a bunch of these that just didn't, these are just like hack ideas that didn't get off the ground or something, or they just serve their purpose as quick tests or whatever. A lot of these I just, forked some stuff, but didn't contribute to them meaningfully. A lot of these are, it's like I made a bunch of separate models that were actually part of something else. Some of these were just bad ideas. And then we have 24 left that are actually kind of interesting, and I chose 5 of these to talk about. So the ones I chose, they're called Rust Oslo, which is, well, I'll actually just get to what these are. Just dive in. Rust Oslo is one of the projects I work on most. This is a Virtual Boy emulator. It's one of the more accurate ones, which is kind of cool, but there's still bugs. It's been working on it for a little over a year. It's 100% Rust at the top level. It exposes a C API to another front end. We'll talk a bit about that. And I live stream a lot of this, so if you guys want to see some development of that, I recommend you kind of check that out. I wanted to actually demo this, because it's kind of neat. Ooh.
I unplugged the sound cable because it was making noises.
That shouldn't matter. I think we're desynced a bit, but it should catch up. Yeah, we are really desynced here on the audio. See if I just do it again. That helps. If not, it's not too big of an issue. Does this work fine? Let's find out. The audio's crap. I'll just mute it. Doesn't seem to like my external monitor, but whatever. Anyway, the Virtual Boy is this 90s game console that Nintendo keeps trying to do VR in some form or another, and this is one of their earlier attempts. Same hardware designer as the Game Boy. This one was a lot less successful. It actually has two side-by-side displays that are both red LEDs, because those are the only ones that change fast enough at the time. And it's pretty terrible. Not a lot of people own these. Pretty awful system, but it's interesting hardware-wise, so it's kind of a fun thing to emulate. So that's what that is. I won't show too much more, because it's going to be kind of glitchy, I guess. But anyway, if you go to this website, rustoboy.com, you can learn a bit more about it. You can watch the demo here. It's a little better. Stuff about Rust, all that kind of stuff. This is all open source, of course, as it should be for that kind of thing. And where did my little presenter windows go? Okay, that was kind of annoying that I have to open this again. Ah, well. So I don't want to go too far into some of the code here, at least not yet, but if you guys have questions after, I would love to dig into some of that stuff. But I want to talk about some good things about doing an emulator in Rust, about a project that's sort of this kind of scale. One of the things I don't think I talked about is that the emulator has sort of the emulator core, which describes the system and how the system works. And then there's sort of a front end to that emulator, which gives you the window, gives you controller input, all that kind of stuff. Now the front end is actually a separate program. It's called RetroArch, and it's made by these guys who build something called libretro, which is a C API that if you implement that, then you can put your emulator in this front end, and it will again take care of all the boring stuff. We're going to just focus on making the hardware act like the hardware. So keep that in mind a bit. So a couple good things about this. Cargo is really good. So if you guys have never heard of Cargo, Cargo is Rust's package manager. It's like NPM for Node. Anyway, it's really good to use off-the-shelf components. So for example, I use an off-the-shelf library for getting a pixel buffer. I use an off-the-shelf library for audio stuff. I use an off-the-shelf library for command line arg parsing, and also the debugger commands have their own parser. There's Shift.js decoding. The ROMs in this old system actually use this old Japanese character encoding called Shift.js. If any of you have heard of that, I'm sorry. But there's a library for it, so that's pretty great. There's zero hassle exposing a C API from this. So I've done a lot of like .NET and stuff. And if you want to embed like some .NET code in a C++ driver, it's not fun at all. In fact, it sucks. With Rust, it's really easy. So that makes me really happy. Do a lot of native stuff, so that's a really good thing about Rust. One of the things we did here is I actually made what I call zero copy output data paths. And so the emulator itself, you'll run it and you say, okay, this much time in the real world passed, so we're going to emulate this much emulated time. And when that happens, the emulator might produce some new images or it might produce some new audio samples. And when you actually route all those images and the audio out to the front end, you don't want to be doing a lot of extra copies of that data because it's big enough that sucks. So there's zero copy output data paths. This I'm going to break into sort of demo mode here and try to show that because, whoops, that was lock button, not projector button. I'm a pro, guys, I promise. Yeah. Let's try this. Bloop, bloop, bloop. Is that big enough for people?
That's good.
About there, people started grunting, so we'll go with that. Let's actually pull some of this up. There's some kind of cool patterns in here. I know I'll be jumping around a lot, but I think it'll be interesting. So in here, when we actually want to get the data out, I made these types, like we have an audio sync and a pixel buffer. And what's cool about this is that the front end might expect different kind of pixel data types, different kinds of alignment and different kinds of formats, like RGB 555, 565, or 8888 for aligned 32-bit stuff. And you can actually have different kind of pixel buffers. So these are references to slices, which is just a pointer and a length pair. So if we get a slice from the front end that says, hey, core, put your pixels here for this frame, then we can actually tell the emulator we can give it a pixel buffer that's wrapped in this kind of wrapping, which is very safe. And that just goes all the way down. So when the emulator emulates, it'll actually output the right stuff. And basically the same thing for the audio. It's going to fill a buffer, and that's basically it. And these things are actually just really nice to describe with these tagged unions. So I'm really happy about that. And then like the top level emulator code here, we just step the emulator and we give it frame sync and an audio frame sync. Those are the exact types you saw earlier. And then later when it wants to write to those, for example, the video hardware, we just have, okay, run this many cycles and it might output something to the frame sync. So it's kind of happy with the architecture there, and this is the kind of thing that's actually really easy in Rust. I think, yeah. So I just kind of wanted to dig into that a little bit. I'll just continue from here. So yeah, so that's one of the things I think was really kind of good about doing a project like this. The architecture and the code generally is pretty clean. I mean, emulators kind of lend themselves naturally to modularization because you have here's the video hardware and here's the audio hardware. So that's kind of natural anyway, like even in OOP languages. But yeah, still good here. The threading related codes, for example, doing audio output, you have like a ring buffer that's pulling out audio and pushing it to the sound card. And then you have the emulator that's hopefully pushing the same amount of samples to that ring buffer. Doing the threading there is actually really easy with Rust as well. Basically just use the standard library functions as they're meant to be used, and things don't deadlock, things don't break. There's decent enough CI support. There's not any tests for this stuff, but we use CI to, like, if I want to do a new release, I push a certain tag and it just builds that. So, I mean, even just the fact that AppVeyor has, has Rust images is really nice. And things are generally pretty fast. It's not all daisies and roses. We still have to do a lot of perf optimization, and I've done a little bit of that with existing tools, like Visual Studio can do it a bit if you enable symbols in the release builds. And the, what was it on Mac? I don't remember, but anyway, those generally work pretty well. It's just some unscientific measurements here. I use about a little more than twice CPU of other C++ emulators, and that's not great. So I would really like to improve that. Quality of some of the packages can be a bit shoddy. I know that the audio package we use, which is called CPAL, Cross-Platform Audio Library, it works most of the time. On 64-bit Mac, things don't work half the time, and I don't know why. So there's some things about that. And a lot of that has to do with immaturity of certain parts of the library ecosystem, but regardless, it's still a problem. There's some code dupe for mem mapping. I mean, maybe that's probably my own architecture that I could probably improve. Maybe there's some generic things I could do there, but yeah. And there is some unsafe code used for zero overhead array accesses. So a lot of things like the memory, for example, is just emulated as a big array. And whenever we're doing accesses on that from the emulated CPU, then a lot of that stuff will do bounds checks on those arrays, but we've already like masked off a bunch of the address in order for it to address the memory. So like we don't actually need to do the bounds checks. So I use some unsafe code to get better performance, and that does work. But it's kind of nasty, but we don't use it very often. And the build times are not great. If you guys have used Rust on anything non-trivial, I'm sure you know this. Incremental compilation should help. I haven't done enough testing and measurements recently because I try to keep this on stable Rust. But I think in the most recent it came out, so I can't remember. Anyway. So back in late 2015, I wanted to do more emulator stuff. And I needed an audio library. And at that time, CPAL, the one I mentioned earlier, was really crap in OS X. I think they removed support temporarily until a couple of the other libraries got a little more stable. So I started contributing to Core Audio RS, and I wanted to share this experience because this was the first thing that I had done where I contributed to someone else's Rust project. So it's basically just a thin wrapper over Apple's own Core Audio API. And it basically gives you, has these virtual audio units, and it gives you a way to instantiate these, hook them up to other ones, and then just kind of run the audio graph, and things work most of the time. So it's part of this Rust audio group, by the way, which is really cool. They have a lot of projects about reading MP3s and reading FLAC and all that kind of stuff. So again, a bit of immaturity there currently, but I think it's going to get there. Now the original Core Audio RS, the reason why it didn't just work is because the design of it was a little bit, I wouldn't say bad at all, it was just a little bit off. They wanted to wrap a lot of the modules at kind of a higher level than was a bit natural for working with this API. Made it a little hard to wrap and integrate into other things. So it made sense to kind of drop the abstraction level a bit to basically just give a safe interface to the underlying core audio API. So that was, I just emailed the guy who did the project, and I just talked to him about that, and we emailed back and forth. It was extremely pleasant, and then that happened. So I bring that up again because it was a really good example of where, it was a really good experience contributing to that project. The guys were very responsive and was really happy that people were getting involved. And I think generally this does actually represent at least my experience of the Rust package ecosystem as a whole. It tends to be really friendly in this manner. So people are just happy to help. And now we're able to actually expose that existing API in a thin, safe, Rust-like manner. And then, of course, we also have raw C API bindings in core audio sys, which is kind of the typical way you do that. You have a -sys package that's just, here's the C API, but it's all unsafe, and then you do some other thing on top of that. So bad about that, it's still pretty incomplete. That's partially my responsibility, I think, at this point. But it's good enough if you need to get samples in or out from a sound card, so good enough. It's also the kind of thing that's kind of inherently difficult to test effectively, which is one of the reasons why it's incomplete. But by the way, before we move on, maybe actually I want to stop for any questions if you guys have any. Just take a little break. Or not. That's cool. So another yeah.
Just interfacing with C. What does that feel like, and how is that done in Rust?
Yeah. Why don't I just show you?
That would be better.
So there's two sides to that, right? Because you have, I want to write some Rust code and then consume it from C, or I want to write some C code and consume it from Rust. I can talk. How about I talk about one of those? Because I think that's the one I have more code for right now. Actually, no, I have code for both here. I know I just talked about doing a project where I did that, but I don't have that code here. So let's talk about consuming C code from Rust, right? Okay, yeah. So I'll get to which project this is actually in, but basically it's going to wrap the Windows API. So I think I have my own bindings for this, which I'll talk about why later, but just note that I do. So this is Rust code that's going to wrap some of the C API. So we define a bunch of the same types that the Windows API will use. If you've ever touched the Windows API, it is of course very familiar, and it's just aliases for built-in types. All these handle types and crap, so that we can actually bind stuff nicely. So then these are definitions of different kinds of callbacks. This whatever proc thing is the Win API sort of standard way of doing that, and they're all std call. This is your calling convention, and then the function, and then all the arguments. And because we have all those type aliases, we write it basically as if it were exactly like the Win API. This is already kind of interesting because this is a struct, which is the window class extended. This is usually the EX one, so it's the new one. And what's cool here is that we can just make this structure, and then when we do this repr-C thing, it means to use the same representation that the C compiler would have. So this gives us a structure definition that's already compatible with the C one. So if we get like a pointer to one of these structs, then we can just use it as if it had been a Rust structure, except it's unsafe.
Can people define their own representation?
I don't know how many options you have here, to be honest. So that's not a question I'm able to answer. If you don't do that, you get whatever the Rust one is.
Yeah.
I know that, and it's not guaranteed to be the same as C, I guess. Yeah, some more aliases, and then at some point I should have, here. So here we're going to link a bunch of functions from kernel 32, which is what this is doing, and they're all going to be std call calling convention, and these are just the function definitions. So somewhere else there's a function that's going to be linked in from this with this calling convention. We have, for example, exit process, all these other things that you would expect.
So is this currently done by hand, or is
this I did by hand.
Okay.
There are generators for this. I think I don't remember what it's called. If anyone does, please shout it out. But it uses Clang to parse headers and then outputs this exact kind of code. I did this by hand because it's in a size limited context. I'll talk about the project later. But yeah, it just shows you what it looks like. And then so that's just the function definitions, and then we would use that just like we would in any other context. If I go in here, here's my window thing. And again, there's some static and some unsafe crap. Just ignore that. It's not very idiomatic. But here, in an unsafe block, I can just call this same stuff. So it's, yeah. I like it because there's just no magic.
Yeah.
It's native code interfacing with native code. So that was consuming a C API from Rust. The other one is exposing Rust code as a C API. So a good example of that is in that emulator code, because we expose the emulator core to that libretro front end. So that, if we go in Rust Boy libretro, this does exactly that. It's a bit messier because the C API in particular, it makes some assumptions about lifetimes and things, where basically there's going to be some static stuff and there's going to be some other things that we just have to deal with. Like they query some data before we can create a context object and stuff, so there's a bit of messy stuff, but for the most part, it's basically this. We do pub unsafe function and then just do the function definition. And no mangle means it's going to get a C-friendly name. Give us errors if we have Unicode shit in here, I guess. And then, yeah. So this is just exposing these, and then these can be called from C. The only other thing after that, though, is, of course, the library thing. So a Rust crate, which is like a Rust package, has this cargo.toml file, which will tell it like build arguments and stuff. So normally you wouldn't actually have this, but if you do this, then you can specify options for how it's built as a library. So in this case, we specify this name and that it's a dynamic library. And this dylib thing is cross-platform. It doesn't just mean Mac dylib. It means dylib on Mac. It means DLL on Windows. Is that?
That's exactly what I want to see. Yeah.
Sweet.
Now,
Glad I asked.
I'll ask another question if nobody else has one.
Emil?
I'm wondering about string encoding, like communicating with the input to. How do you like do the string encoding? Right?
Yeah. So in that particular example, so I think I only have strings where it's not a problem,
Right.
and I just use the ASCII specific overloads of those functions. The wide char stuff, I think you would need to use a library that gives you wide chars.
Right.
I don't know if libc, which you often link into Rust, which has a lot of these types to find. I don't know if that gives you a wide char string converter function. I know it gives you a C string thing, so
Yeah.
it might just have that. I'm not actually sure. But I'm guessing there's going to be a library for that, where you take a Rust string and it'll give you, be able to get some pointer out of it. Yeah, and Chris had another question?
Yeah, actually, I was just from not doing any Rust, I see mute all over the place.
Yeah.
So I'm guessing it's mutable.
Yeah, so
Is that, so object in OOP languages propagates and you lose information. Like, do you have that same kind of pollution when you're dealing with mute and the borrow checked?
I'm not sure what you meant by losing information.
Like, if you start putting object in function calls, that kind of lack of information is going to start propagating around. Your typing system is not going to be able to infer through.
Yeah, so you're asking if the borrow checker
struggles
gives up when you do a lot of mutable things? Yeah. No, so the borrow checker, I probably should have had some slides in here about basic Rust, but I'm happy to talk about it. So the thing is, in Rust, everything's immutable by default. And if you only have immutable bindings to things, you tend not to have problems. The problem only exists when you have multiple aliases to mutable things, right? So if you make something mutable, and then you want to go and mutate it, that's okay if you're if your scope, for example, is the only thing that kind of owns that object. Or if you take a reference to it that is mutable, then you've essentially borrowed ownership of that, and then you can mutate it, and then you give it back at the end of your function, for example. So it's not really a polluting thing, because like if you make a function that takes an immutable reference, it knows it's going to borrow that and then give it back. So within the context of the function, you have ownership, or you're borrowing ownership, basically. And then outside the context of the function, it's not really a problem, except it knows that that function needs a mutable borrow, and so that kind of propagates.
Nice.
So maybe that's what you mean by kind of like...
That is,
like,
I'm just wondering, so to what extent can it reason through?
Yeah, I'll talk a little bit about that later and share some really good links where you'll want to read more.
Nice.
Yeah. Cool, anyone else? Anders?
Does the compiler give you any sort of metadata at runtime about your code and types and stuff, or is it pure like compiled to binary and
It's basically C when it's compiled. You don't have a reflection API, for example. There are some cases where you can do compiler plugins to augment some of that, but yeah, there's no generally no reflection.
And the programming model and best practices typically don't rely on metadata at all?
No, they don't. Anyone else? Cool. So another project I wanted to talk about is Xenowing. So we're getting into a lot of projects where it's not all Rust. It's just I wanted to show like here's a place where I've used Rust that's kind of cool. So this project is actually an FPGA game console that I'm doing from scratch. I've been working on it for a couple weeks. It's not terribly far, but I've like the CPU cores working, some basic outputs working. It's got a custom CPU, which is a RISC-V core, so that was kind of fun to learn about. It's going to have a custom GPU and audio unit, which I haven't done yet, and then some interconnect, which I'm working on. It's really scoped down in the sense that those are the only things it's going to have. There's no external storage, just a single program ROM, external memory interface, which I actually have generated from my FPGA tools. The thing about a lot of FPGA development is that working on that hardware, especially with the vendor-specific tools which you have to use, is really kind of unwieldy and very slow turnaround times. It's like 5-10 minute compile times for a small project, and that's it. There's not really a way to improve that in that space. So what a lot of people do, and what's a pretty good idea, is you end up with a simulation or kind of emulation-based workflow. So there are a lot of tools that will take your hardware descriptor language code and give you, for example, a C++ simulator. One of them is called Verilator, which is actually a pretty good tool for this. What I wanted to try and do, so when you make these simulators, like, okay, you can simulate the hardware that you've described, but what if that interfaces with something else? So what if it interfaces with a DDR3 module or something? In order for that simulator to be useful, you need to provide a model for that it can interface with. So I wanted to try using some of these Verilator models, but then interface them with Rust code and do the simulators in Rust. And it turns out it works great, and I kind of want to talk about some of that stuff. Yeah, so that's basically what I mentioned. Yeah. I just want to show some of this because it's kind of neat. First, I'll show the just a tiny demo of the actual CPU running. I'm just going to do make test here, and it's going to compile the simulator. So make clean first. Can I bump this up? There we go. Trust me, guys, it'll be super exciting. So it's gonna build everything, and it's building all the simulators and everything, which are built to C++ libraries. And now it's compiling my DDR3 simulator, which is Rust code. And then when it finishes all of this stuff, this is built from scratch, and it's already way faster than the hardware build. There we go. So it ran the simulator, and the LEDs on my output board changed. So there's just a little bit pattern there. And that's all it did, so that's kind of cool. So just to kind of show what some of that code kind of looks like, there's this RTL code. RTL is register transfer level, so this is like a hardware description. And then we use that Verilator tool to generate a C++ simulator. So the C++ simulator, for example, for this test here, it basically gives us an interface where, let's see, yeah, where we just have sort of these getters and setters for the actual state, and then we can change like the clock value and all that stuff. So what I've done with the C++ simulator, this tool isn't particularly conducive to, okay, you have the C++ simulator, let's make that a static library and then load that into something else. It really wants to be the driver of everything. So what I did instead is I made my Rust simulator as a dynamic library, and then the C++ code I can build, and then that takes the dynamic library and loads that, and then uses that as a simulator. That works really well. So this is the C++ wrapper code that just exposes all that again into the structure. And then the Rust code for the DDR3 simulator, for example, can then, actually it's in here that it's linked. Yeah, can also has the duplicate definition for that struct, and then wrappers just Rust functions over those functions. And then my simulator can just be, basic FIFO and command processing and stuff. And it tends to work really well. Now we have a cycle-accurate model, or here, of a DDR3 controller that actually works against the simulated hardware, thus making the workflow nice.
So the cycle accuracy is from the simulation in the C++?
Yes,
exactly. The Verilator stuff, and then you're talking to that?
Yes, and I'm talking to the Rust code, and then the Rust code also knows what the clock is, and so it knows when cycles happen.
Cool. So this is doing like a testing framework?
Exactly. Doing a testing framework in order to make the development not totally sucky. So I can test in, like if I build that again, that's how long my test cycle is. A little bit more if I actually change the code, but pretty quick. Definitely beats 5-10 minutes. So some of the good stuff, Rust helps to make complete and closed models of the simulated peripherals. I'm really in love with algebraic data types and pattern matching. And so as an example, that this DDR3 controller here, it has some things where like it has the current command that it's processing. And the types here is that I have a command, which is either a read or write command. And then I have like an active command, which is either a command or a refresh, which is not one of the commands that comes from the top level stuff. It's one of its own generated commands. And I like this kind of hierarchy of these types because you know exactly which thing is kind of going on here. This is a complete closed representation of that state. And then the whole simulator, of course, has the actual memory, a FIFO for the command queue, the current command it's working on or not, it's an option. And then cycle since last refresh, so it's not complicated. The kind of nice thing, and that I'm really happy about. And the code is generally pretty readable. I think this entire simulator is 250 lines, and it's even doing a lot of error checking and stuff. So that's pretty cool. And of course, all this would have been possible in C++ as well. I just wanted to see what it was like in Rust, and I'm thrilled.
Zooma ett tak till nästa gång vi kommer. Zooma lite mer nästa gång.
So Rust helps to make complete closed models, which is really nice. And the sort of safety and the terseness of the code is kind of a bonus. It's helpful and for a nice peace of mind, but it's really the being able to make a really good description of the entire state that I really like with this. Also, the perf is really good. I haven't actually tested this against like a functional language where I would have written it similarly, but it seems to be great. And one of the things that I haven't quite gotten to, because this project is still kind of early on, Cargo should be really good for pulling in existing libraries. Like again, if I want pixel output when I start doing the GPU or audio output, it should be really nice to use Cargo for those in those kind of simulators. And it might even be a good place to, like, if I start making good patterns around this, maybe it's a good place to upload more pieces of hardware. You know, maybe I kind of smell an ecosystem here. And making a test framework here is probably pretty useful, or using, you know, Cargo test or something. But I haven't really explored that too much yet. But I think it could be good. The bad parts, of course, is that the glue between the C++ code and the Rust code can be a little verbose. But this is the exact kind of thing where, you know, this should be possible to generate. As it turns out, someone tweeted me like yesterday that he actually wrote a generator that generates this, so that's kind of cool. It actually uses a Rust Verilog parser that someone has made. This is what I love about the ecosystem. He found a Verilog parser that parses the RTL code and then outputs the exact interface that I would have written by hand, and it just works, so that's really cool. Yeah, and then again, the Verilator thing is sort of not really that conducive to non-C++ driver code, but maybe there's another hardware DSL that I think I might work on that could do that, so that could be cool. And it's a bit too much early to tell the other stuff, but just thought that was a nice place where Rust can be used. Any more questions before I move on? Yeah. So another one I wanted to talk about was I did the Advent of Code in 2015. How many of you guys have heard of the Advent of Code? How many of you guys have done the Advent of Code? Okay, I don't like to give commands, but you guys should totally do that. It's really, really great. You just get a basic series of programming problems that you solve kind of each day. In fact, I'll just kind of show you, whoops, from not that window, I guess, what that looks like. Just type it in, because I promise I'm good at computers. So it gives you a series of problems in kind of this Christmassy wrapping. It's kind of cute, and I guess he shows an ad, so he makes money. But anyway, you get a problem every day. So like this is, normally you don't have access to this in like a normal Advent. Every day you get access to additional ones. I think in 2015, I didn't find out about the project until day 10. And I did it from days 11 to 14. It came out, I was in the US at the time, it came out 9 p.m. where I was. And so I did it as fast as I could. And then I fell off after a couple days because I went on vacation. Anyway, I wanted to share this because it was, at least for me, it was a really good experience learning the language and trying a lot of things that I hadn't tried. So really good way to do that. It was also a really good excuse to try new libraries. I particularly remember like day 7 used this parsing library called nom, and I probably would not have tried that if I didn't have an excuse to do that. Now I wouldn't use nom, but that's that's another opinion. I really like, there's a library called combine, and there's rustpeg and some other ones. But anyway, really good excuse to kind of just get your feet wet with a lot of those kind of things. There's also a leaderboard here, which can be really motivating. I think leaderboard here, and you can just pick like different days. I think I'm on not that day. It just shows you like the first, I think, 100 people that got it, and I think there were a couple thousand people doing it, so it was kind of fun to do that. The increasing difficulty of those Advent things is really good, so I think that's really great. And then kind of the bad is I kind of wish I had done the whole thing. And some kind of interesting things, the top solutions were basically almost always Haskell. And then like second and third were Python. So, I mean, Rust is cool too though. But I mean, it was just kind of interesting. Just wanted to share that. So the last thing I want to show is some work that I've done. So how many of you guys have heard of the Demoscene? Oh wow, that's surprising to me. I mean, I'm happy about it, but that's a lot more than I expected. So the Demoscene is for those of you guys that haven't, it's kind of this crazy thing where people just want to show off cool looking graphics and audio with software. It's something that I've been involved with in a long time, and it's this thing about just pushing limits. And one of the things that I'm involved with, I'm in a group that does these 64 kilobyte intros. So it's one executable that's your only thing, no external files. And in that executable, you generate audio and sound and everything. So now that I've said enough about that, I can show you what one of these looks like. And then we'll talk about that. We're going to be lamers and watch it on YouTube. Not real time. Because my laptop isn't that cool.
Yeah, I unplugged the cable, so you have to...
No, we're good. Appreciate the support from my lovely colleagues. This is about a year old now. This guy sucks. It is in memory for a short time. So demotivation is the thing that makes all that happen. It's our own tool for doing these. And basically, so you have sort of two parts. That was one, well, if we'd ran it real time, it would have been one 64 kilobyte executable. Runs on a bit better machine than this one, but anyway, it does all the music and all the visuals live as you see them, so they're all real time. So there's sort of two parts. There's the video stuff and the audio stuff. The audio stuff was done in C++. We had that around for quite a long time, and I don't really plan on porting it. There's not much of a point at this point. But all of the visual stuff, including the tool, is done in Rust. Probably this is the biggest and craziest project I've done with Rust so far. There's a lot of pieces here, from executable compression to audio synthesis to the actual development tools to everything. Touches a lot of low-level stuff with no standard library stuff, with using core, custom Win32 bindings, which I showed earlier. There's a custom x86 JIT in here, and there's been a few different incarnations of this stuff, and it's unfortunately a bit closed source. A bit means it's closed source. But I hope to open that up eventually, so we're going to start with the synth and then open up everything else eventually.
You said there was an x86 JIT in there?
Yeah, there is.
Oh, just throwing it up. Piece of information.
Yeah, it's not that important. So I wanted to actually show that tool, because it's...
Yeah, go on YouTube, Jake. Show us your tool.
I love that I work with adults at Fuse. And by the way, I'm totally as childish as them, just not when I'm speaking in front of people. So I made this window really small so it runs fast. Anyway, this is kind of the tool. It's a bit confusing what's going on here, but we have a little profiler down at the bottom. This can be loud. And then this is kind of a visual programming language that describes everything that's actually drawn by the CPU. I know it's hard to read, but that's because it needs to be small so I can actually see what's on there when I'm working on stuff on this laptop at the party. So this is just basically it's a visual language for sort of orchestrating OpenGL calls. And it uses a lot of shaders and stuff as well, and it has things like reload. So like if I go into Sublime, for example, and I go and I change some stuff, we're about to hear my fan get real excited. Go into demos, you can do assets, I'll do one of the post-proc ones. This one. We can change some shader code, like this one, and that'll just reload when we save it in Sublime. So that's a big part of the workflow, and then actually changing stuff here, which might be a little hard to show effectively, but if I move stuff changes. Kind of the idea. Anyway, this whole thing gets jitted into x86, both in the intro itself to make it smaller, and also here every time I make a change in this graph. And this is something I like to do here, by the way, is I like to just go nuts here, because I like to show how fast this is, and just smooth this whole tool is, and the fact that it's just not at all breaking with basically anything I do, and I can copy and paste and stuff here too. And then I have unlimited undo as well, which is really nice. So that's also why I like to do that, because I can undo it. So that's nice. So some good things about this project, again, it touches a lot of stuff. I'm really happy about that. The actual logic of the tool, particularly the data model and under-redo and stuff, is really nice. That actually is all in Rust. And then I expose a C API, which has a small C++ wrapper, which is then consumed by Qt on top, which is what I'm using for the UI. And that ends up actually working pretty well. The layers in between with the C API and everything is a bit verbose. It's trivial, the actual stuff it does, but it can be a bit verbose, but that's something else. Again, ADTs are awesome for describing complete and closed, like the model state space. Resource management and the file watching, the stuff when I change a shader and it just works. That's really robust in Rust. This thing just doesn't crash. And Rust really shines there because it's, we have several threads watching several different kinds of files. I have it supported in the shader language that you can include other shaders and include other pieces of code. So like this stuff, and it will, of course, recursively, as it's pulling in all that data, add those to file watchers, and all that works. And so there's a ton of threads doing that, and then they all push any updates that happen onto a queue, and then the queue is consumed on the UI thread. And all that is guaranteed by the compiler to actually be safe. The CABI compatibility is really good, which we need because we link in that C++ stuff. Generally, that stuff is really easy. Rust C code gen is actually pretty suitable for small code size. It's, it generates good, small, repeatable code. The performance issues are pretty rare. Mostly in this tool, they're in the UI layer, and it's because I do something stupid. If I use Qt how you're meant to use Qt when you want things to be performant, it works pretty well. And this, like I said, this thing just never crashes. I run this thing for 2-3 days at a time, and it's just fine. And yeah, it's kind of crazy. I don't believe it a lot of the time, but it keeps happening. I'll take that as something good. Sublime actually crashes more often than the tool does. I mean that as my tool is cool, but
Just have a lot of RAM.
I don't think so. It doesn't leak. Rust makes it so it doesn't leak. Well, unless the driver leaks or something, but nothing would help me there anyway. Some bad stuff. No STD Rust, so Rust without the standard library is pretty good, not great. You're suddenly missing a lot of things that you would like to have. You still have the ADTs, you still have all the basic stuff. Suddenly you don't have vectors, suddenly you don't have things that require copies. It's a pretty naturally restrictive environment, so I mean, it is what it is. And it's no worse than doing C++. I used to do these in C++ before doing them in Rust, and it's no worse than that. It's not really better for that use case. I think most of the advantages that we got here were in the tooling, not in the actual replay or executable. It is pretty verbose bindings to hook everything up to a decent cross-platform UI framework. Now we actually only use this on Windows, but for a time I had this working on Mac as well, because I was using that a lot. It's doable and it's trivial, and maybe some of this can be generated. Not really sure. I haven't really played with that. Probably it would work. C might be a better choice for some of the lowest level bits, because it would be nice not to have to write a lot of these bindings by hand. At the same time, though, it's really easy to keep those as a Rust library to link them in, because there's like our GL abstractions, the tool and the intro use those, so maybe that's nice. And sometimes in Rust C, of course we use a lot of nightly features. Those do change, as you would expect from a nightly. So 6 weeks before we were going to release one of these, we say, okay, this is the version we're using, and then that's just how we deal with that. And that works okay. I think there's been a couple painful upgrades, but not too much.
One question for you, Nick. You were saying nothing that requires copies for no STD? Or did I mishear you?
Yeah, I think it was if you copy sufficiently large structs, you don't have memcopy, so you have to fill that in. So there's a couple things like that that you need to do.
Gotcha.
I think, though, that Rust's core library, which is kind of like a minimal subset of the standard library that you can use without the standard library, actually supports a lot of this stuff. So I don't think it's a big problem, but yeah, there's some of those things that we have to fill in for that to work. I think it was what it was. So I had some general kind of conclusions about sort of my experience of Rust over the last few years. Before I get into that, is there any more questions? And I hope to have more questions at the end too. Yeah?
I kind of didn't get it. Is the tool in Rust or the demos in Rust or both?
Yeah, so the demo is in Rust and the
Okay.
tooling is in Rust, except for the synthesizer that does the music. That's in C++.
Okay, and that includes the 64K demos?
Yes.
In Rust. Awesome, yeah.
Exactly. And of course a lot of shader language too, but
That's right.
you would expect that. Yeah?
Does Rust have any general drawbacks in terms of size optimization?
Not really. Not any more than I've had with Visual Studio, for example, with its C++ compiler. I think we're actually losing a bit because we use two different compilers that have different float models. I think we lose some redundancy there that we could take advantage of with the compression later. I haven't tested that, and it hasn't been a problem. But yeah, it seems to be okay.
So like I don't know Rust, but is there anything in the new primitives that it introduces for memory management and stuff like that has any runtime cost, or is it all compiled?
No, so actually a lot of the stuff for memory management, it's basically RAI from C++. It's just it tracks ownership across like function calls and things to make sure that the lifetimes are actually okay. So it doesn't actually introduce anything more at runtime. It does have some things like reference counting and stuff that you need to use at that time, and then you're explicitly using a reference counted object. So that would of course incur some runtime overhead, but depends on what you're doing.
But beyond that, it's just compile time checking.
Yeah.
It's pretty sweet.
I'm pretty happy about it. So some general conclusions. I wanted to talk about Cargo. So Cargo is again a package manager. Cargo is really, really good It's really easy to get new projects and lib started. The module system makes moving code really easy between crates. That's a little bit more on the language side as well, but just the fact that it's all kind of, it feels very naturally integrated. It's a lot of design decisions that work well together. Pulling in dependencies is always really nice, and even if you have your own folder structure and just having relative dependencies and stuff, it's just really nice. The UX for using Cargo is like miles ahead of C++ because like I don't know a lot of package managers in C++ that actually work and have packages that I want to use. I like it a lot more than .NET because I don't really like using NuGet. NPM is pretty cool, but stuff tends to work when you get them in the Rust packages and not break later. And you don't need to set up 20 dependencies and transpilers to start your project. That's pretty helpful. TypeScript. Until it isn't good, though. Cargo's pretty good until it isn't. Integrate, particularly the biggest pain point I've had, especially with a lot of these projects where it's like Rust is one part of a larger thing. Integration with other build systems is not great. I wish it could be made better, but I think people are working on it, but yeah, that's kind of a pain point. You can't really expect everyone to drive everything from Cargo. A lot of times you can use like a build script that's also written in Rust for Cargo to build things like C libraries as part of your project build. But that doesn't necessarily work if your Rust project is the C library, for example. So it's, yeah, there's things that need to be a little bit better. I don't think it's entirely usable offline. Even if you have pulled some of the packages, I think it still tries to call home, and that's not great. And a lot of the ecosystem for the crates is still pretty young. And that's, of course, less of a diss on Cargo, and just it's a young thing. It's not really anyone's fault. It's something we have to deal with sometimes. I want to talk a little bit about the learning curve of Rust. So I came from a C and C++ background, so like Rust references were generally easy to pick up. I think I spoke with someone here who I find it hard to imagine that would be as easy to pick up from someone who wasn't used to thinking that way. And I definitely think, at least from what I've seen in a lot of the documentation, maybe that can be made better. Because I don't think they're hard concepts, but they might be weird concepts for a lot of folks, and I think that's a really valid standpoint. The lifetimes and the borrow checking, it does you a lot of favors. It makes awesome code. Sometimes learning its rules and what it likes and what it doesn't can be kind of its own paradigm. Now I'll get to a little bit more about why I call it kind of its own paradigm, but even if you know a lot of the rules really rigorously, it can still take a while to get a feel for what will and won't work, which you need to kind of, like you need a feel for it to not think about it. And so getting to that point you ride the bumpers a lot. Luckily, the compiler is really good for telling you when you're doing something wrong or doing something it doesn't like, and it gives you a lot of errors, which is really helpful for coding that way. But it can take some time. I have a link here, and by the way, I'll share the slides on the meetup and everything. It's just a Google Slides thing anyway, so I'll just share the link. Anyway, I found a really good article. It's actually in the Rust source. It's the README in that directory for the borrow checker. It goes in very, very fine detail about how this works. Probably, it's not a light read. It's not something you just want to read if you want to have a basic overview. I'd recommend the Rust book for that. But if you're really curious and kind of hardcore, it's a great read. So, or maybe hardcore is the wrong word, but if you really want to dig into it. I really like the functional bits of the language, like the ADTs and the pattern matching. I feel like they're really natural, but maybe to someone who isn't used to that, they may not be. Your mileage may vary. But I think the language feels fairly cohesive. The book, which is the Rust book, if you go to the Rust website, you'll find the book in their documentation. It's generally really good. I honestly think, though, it used to be better. And the main reason is that they've had the book 1.0 for such a long time. And for at least the last year or so, they've been working on the book 2.0, the content of which is really good. It's really well written. The problem is Google sees both. And when you Google something, you will find links that are mixed in both. And you might find links for something that's not done yet, or you might find something from the old book that hasn't been done in the new book that isn't actually documented. That's a problem, and that I've definitely found that personally to be something that's not particularly enjoyable. But even after you've been using Rust for a long time, just skimming the book every now and then, it's a good read. It's a pretty good thing. So the book is generally good. You just have to be a little careful with that these days, which is unfortunate. I think people seem to struggle with slices. Half question mark, because some people do, some people don't. I think the thing I get asked most is, when do you use slices? That's a hard question to answer, but usually it's when you need a view into sequential things, but it's not an iterator, so it depends. Generally, I think the core of the language actually does feel pretty small, but I don't feel comfortable calling myself an expert. There's a lot of things in the standard library, and there's a lot of details that I kind of often forget. You also have this like into and from pattern that when do you use which, and a couple other things. A lot of the best practices aren't always stated, but things are stable, so if you find something that works, it will continue to work. This leads me to strings. I needed its own slide for this, and those of you guys who have used Rust will understand why. I think generally strings in Rust have a bad rep. The main question is, why are there two string types? And the answer really is that there aren't. By the way, how many string types does Haskell have? You don't have to answer.
One that you should use.
Yeah. One that you should use is a perfectly fine answer, and
Everyone disagrees on which one.
I won't go that far, but I like the jokes. Anyway, the strings have kind of some weird things, like they have linear index time. How do you split an own string into two own strings at a given character position? It's actually not that hard, because you can do split and then collect into two other strings, but you kind of have to know that. It's not just a string is always a string and you always get strings out of it. You often get strings and string slices. That, by the way, I forgot to explain that. You have strings, which is your own string type, and then you have string slices, which is just a view on the character data, in particular a view on the UTF-8 bytes. And that's actually it, but it can be confusing, especially when you're learning the languages, because the type of your string literals has a lifetime in it, and there's some weird things. But it's actually not as scary as I think it looks up front. But I think it confuses people, so that can be something interesting to think about. So I'm a little curious, though, about why people hit that early on, but I do think it's mostly because a lot of initial programming tutorials and stuff will start with some string manipulation, I guess, because it's easy to see. I would argue that if you're not treating UTF strings as black boxes of bytes most of the time, you're doing it wrong. Come fight me. Some things are missing, to be fair, like proper grapheme support, which actually does make some of this stuff kind of bad. I know that there's some unstable support for that, I think, and that I would expect to come eventually, but that's a hard thing to get right, so I'm happy they're taking their time with it. I mean, the C and C++ story is like external UTF-8 lib or bust, and I won't talk about C#, but yeah. The strings are kind of messy, and in Rust you kind of hit that early, but I think it's okay. I just wanted to talk about it. C interrupt. I am really pleased with this generally. It just works most of the time. There's no runtime mangling, like in terms of bootstrapping a runtime and making that work. Minimal marshalling, like as long as you use the basic types, you have the same basic types in Rust, so it just works. This goes both ways to and from C, of course. Building can be kind of awkward, like I mentioned in the cargo slide. But translatively, this also applies to languages that have C interrupt. But I think I mixed up these points. I actually meant to say that like it's good, except it's good, and you can also do any language that interrupts with C. You can use sort of C as the lingua franca between them. Caveat, of course, is C++, which yeah, it's awkward because a lot of C++ APIs are macro heavy or class heavy and need a big runtime, and there's some issues there. Name mangling as well. But again, if you go through C, it's not really a problem. I actually tend to prefer exposing a C API from Rust that's consumed elsewhere than the other way around for a lot of the projects I'm doing. And this, of course, depends on your overall architecture a lot, and it's not really an absolute. It's just something I tend to like doing, and it seems to work. So mention that. Anders?
So what does a Rust string look like from C?
From C?
Yeah.
So, well, if you have the actual string type, like the owned string type, it doesn't look like anything because you can't really get at it. If you want the data from there, you can use its slice, which is going to be a pointer to a bunch of UTF-8 bytes and a length. And then that way you could wrap that in, for example, another C++ type.
So if they can't get it, is that part of the strictness around their...
No, I actually think you could get the layout of the struct and describe it that way. It's just not something you would necessarily do.
What does a dot string look like in C?
Right.
Yeah, that's a good demonstration of that question. Yeah, is that it's you want to treat those as opaque, I should rather say.
Yeah.
The string slices are just basically like non-null terminated const char pointers with a length.
Right.
Pascal strings.
What?
Pascal strings.
Pascal strings.
Right.
That's not a reference I know, so but it's something that he will know, so I'm happy about that. Great. UI. This is generally, I think, an unsolved problem in Rust. For cross-platform UI, I think that's generally the case that that's an unsolved problem. There's a reason I work at Fuse. And there are some promising developments. Conrad is a pure Rust project that moves forward slowly but surely. There's different Qt wrappers. That's kind of a hard problem because a lot of, again, Qt especially has a lot of macros and is a very C++ centric API. I don't think they even have any official C bindings. I would love to be told that I'm wrong. There's some ImGUI wrappers that I haven't tried yet, but I guess they're pretty good. And yeah, if you need a web UI, you can make a Rust server. I haven't tried that. It seems pretty great. I've seen a lot of people do that. But yeah. Mutable object graphs. This actually came up, I believe, yesterday morning from one of my colleagues. That he runs into this a lot. He's a C++ programmer that does a lot of mutable object graphs, and that's a problem in Rust. Generally, the bar checker doesn't like this. If you have a lot of nodes and they all have mutable references to other nodes, you're kind of screwed. It's kind of an intersection of two main problems. You have the lifetime because, yeah, I have all my nodes and they have references to other nodes. Who owns those? Maybe that's an easy question. Maybe it's not. And then the mutability, which is you can't have multiple mutable aliases to different things, and the bar checker will not like you if you do that. If you try to do that, rather. There's generally a lack of consensus on how to handle this. Like generally, it seems to be a case-by-case thing, which I guess is okay, but it seems like generally in the community that also we're not really sure about this yet. This is one of those things where this whole bar checker experiment, I think, needs some more time to settle before we can answer these questions. Really generally, which kind of seems like it's crap because this is a general purpose programming language and you can't use some of these patterns. I mean, technically you can. You have this thing called cell, which is going to give you an immutable alias until you actually try to mutate it. You can borrow the thing that's inside it, for example, and you can wrap this in a ref counting primitive, which gives you something that's essentially the same as a similar mutable object graph in, I guess, Swift or Objective-C, with a little bit of extra either opt-in runtime checking that the borrowers are actually unique, or no checking and then they're unsafe, and that's fine. Of course, you can avoid all of this if you just want to use C pointers, which you can just do, but that kind of sucks. And then, of course, if you're using ref counting, you might have ref loops, but you might be able to use arenas, and then you have references, and those references you might be able to explain that the lifetime is the same as the arena. Sometimes that works really well, sometimes it doesn't. So that can be kind of hard. There's this really good resource, though, here, and again, the link will be on the slide, and I push that out. This whole thing, the R4CPPP, it's Rust for C++ programmers, and it's a really good article series, generally, if you guys are curious about that. And it totally has, this link in particular is about graphs. It will tell you this stuff and a lot more about how to deal with it. And so I really want to share that and recommend that. It's interestingly enough something I don't run into that often. I don't know if it's the way that I architect my code or just the projects that I do. It just doesn't seem to be much of a problem for the things I'm doing. And I'm not going to claim that that's because I'm doing it the Rust way all the time or whatever. I don't run into it as much as I'm seeing people run into it. So I find that kind of interesting. You had something on this?
You mentioned arenas. I was just wondering whether that's something that is a language level concept in Rust, or is it just a pattern?
It would be a pattern, and there's libraries to do that. You can do custom allocators in Rust.
But would that mean actually juggling pointers at runtime, or does it have something?
Well, so Rust references are technically pointers, but they have lifetime data associated with them at compile time.
Right.
Depending on the mutability, if they're all immutable, but you just want them to be owned by the arena, you can just describe that by saying all the references that come out of the arena have the same lifetime as the arena.
Wow.
And it just works. When you want them to be mutable, things get messier, and that's probably not the best pattern. But yeah, that has worked pretty well. And you can do that with you can have typed arenas and stuff as well that are pretty nice. That's pretty great. But yeah, I'm not ready to just write that off as other people aren't doing it the Rust way, and I am. I just don't know. Anyway, that's all I got. So thank you guys so much. Yeah, I was going to open up for any questions or whatever, but if you guys have some, great. If you don't, we can just hang out. What's up, Andreas?
I'm a Rust programmer.
Yeah.
I do a lot of hacks.
Yeah.
As you know. For me, like ADTs and pattern matching is sort of like the hallmark of like a modern language.
Yeah.
So whenever I see that stuff, it makes me really happy. It's like why I want to do more Rust stuff.
Sure.
But it tends to, like in a language like hacks, that generates a bunch of code for you, right?
Right.
And typically that comes with some overhead.
Yeah,
So
so,
really
so it
curious
comes from
about
some overhead
pattern
of
matching
detecting the
ADTs.
tag and then doing that
What
stuff.
does that mean for the C output? I haven't actually seen what Rust produces.
For the C output,
I mean, you know, performance essentially.
yeah, so if you've ever used the tag union pattern in C or C++, it's exactly that. There are some cases where it can optimize, like if you have an optional of a reference, it knows that references can never be null. And so it can do things like actually remove the tag field and just use the pointer and whether it's null for some or none, and it will actually do that for every kind of struct that looks like an option. So if it has a none and a sum with a reference, it will do that. Like there's some kind of magical things, but that's probably the most magical thing it does. I generally like Rust because it isn't magic, but that's one of the things it does. So you would have the same performance as you would with that kind of pattern matching in C++. Usually though, with those tags, those aren't going to be references to other objects. So sometimes you have better cache coherence. I can't prove that, but I just know that's the case. Like I know how it works technically, so I would say that you would generally have that, but I haven't tested that it would be better performance. I just think it would be.
So you're not like performance aware when you're writing code?
Not generally. Sometimes you are. Like for example, the default hash map and hash set implementation use a hasher called siphash, and that is really good for avoiding collisions. So you can avoid a lot of vulnerabilities that come from making your hash map too slow to be usable. However, that's a really bad idea if you just want to make hash set that is going really fast in, for example, a data compressor. And in that case, you can just replace the hasher. But so there are some cases where you will still need to be performance oriented. But yeah, it generally works really well. Chris?
A lot of the CPP-Con talks have been focusing over the last couple of years about infinite behavior and things like that.
Mm-hmm.
Can't get away with that in lower-level languages. So how does Rust address that? What is the compiler that you use?
Yeah.
What's going on?
Generally, there is less undefined behavior in Rust than there is in C++. I actually don't remember the second half of your question.
Is the compiler allowed to abuse it?
Is the compiler? Yes.
Like, what kind of
So it's hard for me to come up with an example of where it would do that. Yeah.
One good example, since you already mentioned this, is the ordering the C representation of structs.
Mm-hmm.
Because in C, the ordering in structs is defined.
Mm-hmm.
In Rust, it's explicitly undefined, so
Okay.
that the compiler can shuffle.
Gotcha. Yeah.
Yeah,
That
that's
is one
great
example
answer.
of a simple example.
Cool. Thanks. Yeah, that's a great example.
Yeah.
Yeah. So yes, there is undefined behavior, and it will do things.
Can you enforce the ordering though when you need to?
Yes, that's the refer C.
Yeah, so I was going to say, if what he says is correct, then Ripper C will do that, and it'll give you this whatever C would have done, and that's fine, probably. Sorry, did I see a question over there? I guess not. No. Yeah.
I'm curious why you don't like NOM, and also you haven't said anything about macros.
Right. Yes. Those are related. Yeah. So NOM is a parser combinator library, and a parser combinator is things like I have a thing that parses an int, I have a thing that parses a string. I can combine those in different ways. For example, one then the other, one or the other, those kind of things, and I get a new parser, and that's how you build parsers. NOM is a particular parser combinator library that uses macros, presumably for performance, that it will generate a really fast code for a parser when you use that. I have found when using that, it's not, I wouldn't necessarily say that NOM is bad. It's when you're working with that kind of code through macros, the error messages are really hard to read. I found it really difficult so I wrote a Blitz Basic compiler, which is Blitz Basic is some old Amiga language, and I really cut my teeth on that stuff when I was younger. So I got some of my old code to compile with that. And when building a parser on that scale, for example, I found it really hard to work with. And it had some issues as well that I probably should have reported properly, but they were like, when you get to the end of a string, it would mark some things as incomplete, whereas another optional could have been a complete match, and it just gives up. Okay. So there were some corner cases there that I ran into as well. So those are the two reasons why I didn't like that library as much. Combine, which is one I've used quite a lot now, isn't macro based, and just that makes it easier for me to work with, I feel like. Yeah. I don't know if that's a great answer, but that's the one I got. Yeah. Anything else? Yeah.
On the perf of the VBoy.
Oh, sorry, behind you.
Sorry. You talked about low-level interfaces with C and stuff. How is it interfacing with the assembly, like inline assembly or something like that?
Yeah, so I actually haven't tried if Rust can do inline assembler. I don't know if it can actually. Yeah.
It has been one of the pain points for a lot of people for a long time, because they had a really hard time coming up with an interface, but the RFC was just merged.
Awesome.
So now they are working on implementing. They have decided on an interface, but now they have to implement it and then do the stabilization process.
Is that all inline assembler or is that SIMD?
Maybe I'm mixing them up.
Because I think that's SIMD.
SIMD was.
Yeah, because SIMD was definitely merged. But
yeah,
maybe
SIMD just turned to stable.
Yeah.
Right.
That might be the confusion.
Okay, so I hope inline assembler is the thing you're talking about. It might be SIMD.
Now I'm unsure, but yeah.
Sure. Yeah, I am as well. Anyway, yeah, SIMD was at least one of those things where it's getting nicer. I'm really excited about that. There has been the SIMD library where it's been nice. I guess that's not really inline assembler, but that is a place where you would use something like that a lot, and that, at least my experience was that was really good. But yeah, I haven't explored that further.
But at least it's not unstable now in inline assembly. So
cool. Or SIMD.
No. Inline assembly is not unstable.
It is not unstable.
Yeah.
Right.
If it is, people are working on it, but how far along it's what I'm unsure about.
Okay. Yeah. That's great to know. Anything else? Chris? Yeah.
I was just going to ask on the VBoy emulator, like how do you separate performance, like you had some overhead?
Yeah.
How much of that is to do with precision of the emulator, and how much is to do with code?
So I'm a bit unsure to as how to answer that question. I know that last time I did profiling, which was a while ago, I was getting a lot of my inner loops in the CPU, for example, were not great. There was a lot of overhead there. I suspect replacing that with a JIT would do really well, but then we would get less cycle accuracy. So I think that'd be worthwhile trade-off. It's also something I want to do for fun. But yeah, I suspect honestly it's just that I haven't explicitly optimized the code very much, and maybe it's a solvable problem, but I need to explore more before deciding that we can be on par with C++ there. Should be able to be, but I won't believe it till I see it.
Are there any conceptual caveats that could prevent it from becoming equal to C++?
In my head, no, but I know that I've talked to some guys who do a lot of optimization with C++ and really don't like Clang and the LLVM backends. Rust uses LLVM as a backend, and it tries to look like Clang from LLVM's perspective to try and take advantage of as many optimizations as possible. That said, I don't know if I want to blame the backends yet either. I need to explore more. So, but as far as I know, there's nothing, especially in the code, in that particular code, that would make it slower inherently. But I'm not sure.
Were they saying what they didn't like about Clang? LLVM?
No, he just said it did worse code. A really insightful guy. I should have asked him more. But, yeah, that's all I got.
I think we maybe should take more questions later. And just
yeah, it has been a while, hasn't it?
Yeah. So I guess you could understand this is the top of the iceberg of what these guys have to talk about. So I hope we can do this more.
Yeah.
And I also know that we have 2 more things that we want to do. A coding dojo. Knappen wanna do that with Rust. And also Vegard has promised to have a presentation of something. He has also a lot of very interesting projects. And I totally forgot about the Rust user group. So Flavio, do you have something to just tell about the group?
Thank you very much for sponsoring this talk. It was a very good talk. And
thank you.
Who's is our first sponsor, so it's a very important for our community. That very young community, and they are growing. And thank you for all the people that attended. And yes.
Yeah, absolutely. It's very fun that so many people showed up.
It's crazy.
And the last meetup was basically we talked a lot about what we could do to grow the Rust community more in Oslo. So again, if more of you guys now have something to talk about or suggestions to like how we could get more interest around Rust, so please talk with Flavia. And also we at least have these two things that we want to do at some point. but yeah, just feel free to call me more. And there's more beer on the way, so please also stay around and talk with. There's a lot of just generally. There's a couple of Fuse guys over there that are just generally interested in programming. So
yeah, look for the children.
Yeah. So just stay basically.
Very good, Jake. Very fun.
Thank you.